Hello, my dear students. Welcome to the another online session. Hopefully, all of you are good and safe. This is the last session of the sterilization and disinfection. And one more thing I want to share with you: sterilization and disinfection topics is very important in community medicine as well as microbiology. So I'm trying all of the things in putting together so that you can understand very easy way. Okay, my dear. So I'm going to start my session. I'm Dr. Ankur is here to conduct you today's session. So let's go. Number B, agents that denature proteins. Number one, acids and alkali. Antibacterial activity by free hydrogen and hydroxyl. By altering the pH used in food and pharmacy industry. Example, sodium hydroxide, sodium carbonate. Number two, alcohols. Alcohols kill bacteria, fungi, but not endospores or net virus. Act by denaturing protein and disrupting cell membrane. Used to mechanically wave microbes off skin before injections or blood drawing. Not good for open wound because cause protein to coagulate. So if we can summarize the alcohol, we can say that alcohol kill the bacteria and fungus by mechanism of denaturation of protein and disrupting cell membrane. This is the key point. Okay, and we cannot use in the open wound because of protein to coagulation. Okay, next, ethanol. Drinking alcohol optimum concentration is 70%. Isopropanol, rubbing alcohol, better disinfectant than ethanol. Also cheaper and less volatile. Methyl alcohol. It is effective against fungal spores, so used for treating cabinets and incubators. Toxic and inflammable. Number C, agents that modify functional groups of proteins and nucleic acids. Number A, heavy metals. The salt of silver, copper, and mercury are used as disinfectants, act by coagulating protein, marked bacteriostatic, weak bactericidal, and limited fungicidal activity. Mercury chloride and silver nitrate are commonly used. So if you can say summarize, you can say the heavy metal is a silver, copper, and mercury. Okay, which are we are widely used, and it is worked by coagulating the protein, and it is a marked bacteriostatic and weak bactericidal. Okay, it is used bactericidal for gonococcus, prophylaxis of ophthalmic neonatal in newborn and to prevent infection of burn. Number B, oxidizing agents, halogens, chlorine and iodine, bactericidal and sporicidal. We can categorize two. And the iodine tincture alcohol solution was one of first antiseptic used, and iodospores providing iodine for wound infection. Providing iodine we are widely used for wound infection, and the chlorine when mixed in water form hypochlorous acid. So what is going on? If chlorine and water is worked and it created and then reaction occurs, then what will happen? That is a hydrogen, chlorine and hypochlorous acid is formed, and it is used to disinfect drinking water, pools and sewers. So if your examiner is ask you why you are using the chlorine, you say that sir we are using for disinfection of drinking water, pools and sewers. Hypochlorite is commonly used and have bactericidal and fungicidal and virucidal and sporicidal. Its uses for sanitizing food, dairy industries, as sanitizer for house and hospitals, as bleaching powder. In now the COVID situation, we are know that we are all of we are using the sanitizer. So this is the main material. Okay. Then hydrogen peroxide, 3 to 6% concentration is used and is puricidal and used to disinfect plastic implants, contact lenses, and surgical processes. So if your examiner is ask you where we are use the hydrogen peroxide, you say that sir, we are use this hydrogen peroxide in disinfect of plastic implant, contact lens, and surgical processes. And we are using a 3 to 6% concentration. Okay, not more than. And we also see a picture. There is a sodium hypochlorite solution picture, and where and that there is a code name is a Clorox we are seeing in the picture. Next one, dyes. Number A, aniline dyes, derivatives of tripenyl methane. Derivatives of tripenyl methane. Example: brilliant green, malachite green, and crystal violet. Active against GPC, then GNB. We have already explained what is the GPC and GNB and used in preparation of culture media. Number B, acridine dyes, flavin, yellow color, bacteriostatic and bactericidal. It is active against GPC than GNB. Example, profalbin and acryfalbin. It is used in wound infection. Number 4, alkylating agents. Number A, formaldehyde. Formaldehyde denaturation of protein, bactericidal and puricidal, virucidal, and fungicidal. Used in liquid and gaseous phase. And 37% formaldehyde, formalin, and toxic and irritant. Okay, if you can summarize that, we are widely using the formalin, which is the 30-70% of formaldehyde. And how it's work? It works by the denaturation of protein. And where we are used for the bactericidal, sporicidal, and virucidal and fungicidal. Okay, this is the key point. Okay, next one is a glutaldehyde. Glutaldehyde, what is going on? Glutaldehyde degenerates the protein is same as formaldehyde, and it is a bactericidal, virucidal, fungicidal, but less effect in spore. And 2% glutaldehyde we are used as co-stalent for disinfection, surgical instrument, and endoscopes. Here we can also see a picture of the glutaldehyde sterilizing and disinfecting solution. Next one is a vapor. Is a phase disinfectant. Number 1, ethylene oxide. Action is due to its alkylating amino carboxyl, hydroxyl, and sulfadiol group in amino acid. Has high penetration power. A colorless liquid but used by mixing with the inert gases like carbon dioxide, nitrogen to a concentration of 10%, using for sterilization of article liable to damage by heat, and sterilization of material like glass, metal, paper, clothing, etc. Number 2 is the formaldehyde gas. Formaldehyde gas used for fumigation of heat-sensitive equipment, anesthetic machine, incubators, laboratory operation theaters, irritant and unpleasant smell. Beta-propionolactone. Beta-propionolactone we are used for condensed product of ketone, and it is a condensed product of ketone and formaldehyde. With concentration of 0.2% we are used. Okay, and has a less penetration power. It is carcinogenic and used for sterilization of vaccine and syrups. Hopefully you will understand. Now, the testing of disinfectant. Number 1, phenol coefficient test. And number A is Riedel-Walker test. Procedure: series of dilation of phenol and experimental disinfectant are inoculated with test bacteria. Concentration and time of action is noted. Result: dilation of test disinfectant will sterilize in a given time. Derivative divided by dilation of phenol is known as phenol coefficient. Phenol equal to 1. Interpretation: phenol coefficient equal to 1. It is equal to effectiveness as phenol, and less than 1.0 is less effective, and more than 1.0 is more effective. So we can understand what is the phenol coefficient test. And number one is a Chick-Martin test, modification of Riedel and Walker test. Keep organic matter to stimulate natural situation. Number two, minimum inhibitory concentration. Lowest concentration of disinfectant that inhibits growth of organism depend upon concentration and time of exposure. Number three is a Kelsey-Sykes test or capacity test. In specific concentration of disinfectant addiction of organism in increments. It is used to see capacity of disinfectant to cope with successive bacteria. Procedure: test organisms are added to disinfectant in three successive lots at 0, 10, and 20 minutes, and time of exposure is noted like 8, 18, and 28 minutes, and subculture on routinely used media. Number four, in use test, test should perform to confirm the chosen disinfectant is effective. Example, in hospitals, disinfectant jar in which discarded materials or contaminated materials are kept for overnight. Subculture and compared with known standard strains. Thank you very much. Hopefully you understand all of the session, and if you have any query, I'm requesting all of you, please communicate with me from my mail, messenger, phone, WhatsApp, what you want, but don't be hesitant. So thank you very much. Stay at home and be safe. Thank you. Thank you very much.